This is another attempt to create a small video demonstrating the GNU-APL mode for Emacs. And let's just get into it, and I'll demonstrate the features as we go along. So let's start it up. And as we can see here, it displays some information. There is a customization settings screen where you can go in and customize various settings, like where the APL binary is located, the port number being used for communication, things like that. And here we're getting a message that explains that the Emacs mode's native backend has been started. It's a native plugin that runs inside of the APL binary and allows the Emacs mode to communicate directly with the underlying APL interpreter. So as we can see, we can type commands here. There is some coloring here. If you type an error message, that should have been red. It's anyway. I can't really explain that. That's basically it displays the colors that are sent from the APL interpreter. For some reason, this was not specified as being an error message. I'll take a look at that later. Anyway, let's look at some simple features. Like, for example, you're able to open a file. Of course, this is Emacs. Of course, you can open files. But this is a file containing APL code, and in here we can see a typical function definition, and we can press Ctrl+C, Ctrl+C, and this will upload the function definition to the running interpreter. So now we can type add 10 100, and as you can see, it prints a message and returns 110, which is exactly what it's supposed to do. If I close this buffer, I kill it completely, and I can move my cursor to the name of a function, and I press meta dot. It will open the function in a separate editor. And of course, I can close it. As you can see, also the cursor is placed at the correct location at the beginning of the function. So let's switch back, and let's take a look at a little bit of more complicated code. So let's simply open up a file that I have created previously that contains quite a lot of code, so we can just compile these functions. Now we have here the key part of the function, and anyone who knows APL has probably seen something similar before. These two lines of code represents the core core function that computes the next frame of Conway's game of life simulation. And we have here a simple function called preload that just loads some variables into the into some starting variables, basically. So we can run the preload command, and after that we have the variable dd, which contains the board, and as we can see, it's a two-dimensional array with the digit 1, or the value true, wherever a cell is alive. So this is a typical walker. So when we run the simulation later, this one will move diagonally up the screen like that. But maybe we want to make this one a little bit more complex. So let's first assign it to a temporary variable, and let's say I want to change some values inside of this matrix. Now, the typical way to do it would be to type something like this, and that would set, let's make it a little bit 15.5, and then I can print it again, and as we can see here, this would be 15.5. It's set that to 1. Now, since we have Emacs, we want to be a little bit more complicated, a little bit more fancy, I suppose. So what we can do is we can type Ctrl+C, Ctrl+V, and type the name of the variable in there. In this case, the variable is v. So what it does is it opens this up in some spreadsheet-like display. So let's set this value to 1 here. We can set this one. We can set a few more like that. I really have no particular plan for this. I don't know Game of Life well enough to make something interesting out of this, but I'm sure at least something will happen once we start this simulation. There, let's add some more. That's enough. Ctrl C, there. Now, as we can see, the variable has been updated. You can see around here all these ones that I set. So this is a pretty nice and easy way to edit arrays. You can of course also put strings or whatever in there, and they will update properly. So let's see how we can actually simulate this and display it on the screen. Now, what we can do is we can simply say that I want to monitor the content of the variable v. Now, in order for this video to look good, the resolution, the size of the window is actually fairly small, so we won't be able to see all of it. But let's take a look at it to see what it looks like anyway. So what I can do is I can simply type Control C, Control dot, which is actually anyway. There's nothing special about that actually. It's Control C, Control dot, and I can type the name of the variable as v, and this will simply display the content of the buffer, of the variable inside a buffer. And if I change something, it will automatically update. So if I go back here to my foo.apl file, and this is some code that will simply update the variable v. Sorry, we don't want to be. Sorry, we want to display the disp. Sorry about that. Let us quit this, and the variable we want to be looking at is disp. So, oops. So we have to give some value to disp. We can then take a look at the variable disp, and we can run this code. This will assign, this declares a function. The function is here. It will simply run this code here, call the next function to compute the next frame, assign that to render that using dots and hashes, assign that to disp, delay, wait for 20th of a second, and repeat this 10 times. So let's do that. And let's repeat that a little bit longer. So let's repeat that for 200 frames. And as we can see, there is a bit of animation happening there. Actually, as you can see, the walker keeps walking up around there. So simulates for 200 frames. Pretty neat. What else can we do? Well, we can, for example, let's do this. And there is one more feature I'd like to show, and that is the documentation feature. And what you can do is you can press Control C, Control A, and you can search for help about functions. So let's say you want to sort. And of course the word sort was not part there, so let's take something else. Reverse. And as we can see here, it describes a number of functions that contains the word reverse in its description. So for example, we can click on this one, and we get documentation saying that it's documentation what this function does. So as we can see, it documents all the various variations of that function. Right, so that's pretty much enough for now, and I hope you guys enjoy this.